Hello, and welcome to today's webinar on how to modernize your database. I'm Jacob Lukowitz, online editor at SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website in about 24 hours after the event. Secondly, if at any time you have questions about or during the presentation, you may submit them using the control panel's question tab. Today's webinar will dive into the differences as well as the similarities between developing modern applications for NoSQL versus relational databases. It's also on how making the move to NoSQL is easier than you may think. Here to discuss this further is Brian Hess. Brian has been in the data and analytics space for over 20 years in roles ranging from government and analytics and data warehousing to NoSQL engines. Brian has master's degrees in both mathematics and computer science from the Johns Hopkins University and started his career as a cryptologic mathematician in the US Department of Defense, working on data science, data mining, and large-scale data research. He is currently strategic solution engineer at DataStax and works with some of DataStax's largest customers. Now, to get things started, I'll throw it over to you, Brian.
Thanks. So, welcome, and thanks for joining us today. I'm going to talk a bit about NoSQL and the like, but let me start with a little bit of who am I. As mentioned, been in the data and analytics space for about 20 years. Started in the Department of Defense, worked at a data warehousing company doing kind of analytics on data at scale, and so sort of a parallel data warehousing company, and that's really where I learned a lot of my SQL in earnest. And then moved to DataStax in a couple different roles. Started in partner technologies, trying to get customers and partners working with applications that work with DataStax, so a lot of ETL and BI and security. Then moved into product management, did some stuff there mainly with analytics, but also some bulk loading and some advanced movement topics. And then moved out into the field to work with some of our biggest customers on what they're doing. That's a little bit about where I am in the space. A little bit about today. So start with kind of a discussion of, in general, why NoSQL is even a thing. Then really kind of dive into how Apache Cassandra looks at NoSQL and how we approached the problem there. And then that kind of moves into, okay, now that we've talked about some of those changes, what does that mean to data modeling and some application patterns? Talk a very little bit about the Cassandra architecture, really just to tee up some of these additional topics that we'll talk to. So that's kind of a very high-level view of where we're headed. Let's just start at the beginning. So you're making the move to NoSQL, and you might be thinking, uh-oh, I'm in trouble, and you're really not in trouble. It really does not need to be painful, and I really don't know who all these they are that talk about this being difficult. It's really not. It's really not, and we should just stop listening to the they in there. So where does NoSQL come from? Really, I've never been a big fan of the way that NoSQL kind of calls out SQL and really highlights that as sort of the thing that's being rebelled against, because I don't think that SQL was really the problem to begin with. The language is nice and simple. It's got a very straightforward way to interact with it. I would like some of the columns of my data from one of the tables and maybe a where clause to indicate which of those rows that you'd like. Tables are a really natural data type. It's really common for data that lives in the world to be tabular in nature. We see it in not just relational databases, but analytics systems and spreadsheets, and it's just a really approachable way to model your data. So SQL's got some really attractive pieces to it. What I think became a lot of the challenge, at least in my opinion, is that when relational databases came out and really put some structure and formalism around these systems, they really made some promises about what they're offering to applications and data owners that struggle when you get to scale. And this is fine when the data was measured in kilobytes, megabytes, even gigabytes. But as we get into the bigger data sets, we really have problems that are going to struggle, and some of these promises that make it easy to maintain the data in a good state, the way that we approached it back then really doesn't work in the modern technologies that are going to need to put many machines to work towards the problem, et cetera. So things, especially consistency, making sure that the database is very, very consistent, requires a lot of locking and coordination that really has trouble as you start scaling out to lots and lots of nodes. So really what that's sort of the approach as to where I think this sort of rebelling against NoSQL was really reaction to the relational model and the relational promises. I also comment, I've been the SQL guy at the NoSQL company almost since I got here, looking at lots of applications that really want to use SQL as an interaction, and I think something that's valuable to the NoSQL market. And I think you see that in the fact that most NoSQL databases actually have created a query language, and most of them look a lot like SQL. So it's not just Cassandra, which has its own, and we'll talk about that today, but you can see that in a lot of the NoSQL vendors also have a SQL-like language. And then all of a sudden, people started revising the NoSQL moniker to really be it's NoSQL, as in not only SQL. And I think that's just sort of a retraction back to the reality, which is, SQL's got some conveniences, and why do I have to throw that out? So it's kind of the space of sort of where does NoSQL come from, and it's really more around where are we revisiting and looking at relational technologies and relational databases a little different. So what's Cassandra's take? And I'll just take a step back and comment that this is one of many takes. There are a number of different approaches in the NoSQL environment that have different kinds of technologies that fall into different categories. There's graph databases, there's these sort of columnar databases, there are document databases, and they each kind of approach the relational model and the relational database a little differently. But I want to focus on how Apache Cassandra and DataStax really look at this. So the first thing I already mentioned on the previous slide, there are some things we like, right? We like tables. The tables are good. We like schema. Schema is something that I think in the big data space and other parts of the NoSQL space, there's sort of this idea that the schema is not that important, and we want to allow for the schema to evolve. And I think that there's a place for that, and Cassandra actually has mechanisms to support those use cases as well. But I think there's the recognition that a lot of the data that people deal with is structured, and there is a schema to it. And having schema in the database allows for some really good data quality and capabilities, that the data will have a schema, will ensure and validate that as the data goes in. We kind of like the language. The language is pretty decent too. Select from where. Those are pretty straightforward. So we'll keep a lot of those pieces as well. The big parts that Cassandra community looked at as areas to revisit are consistency is probably the biggest there. And here what we mean is if we're going to need to scale such that we have more than one machine working on this data as a whole, we're going to need to coordinate across those machines to make sure that the operations are done and the data is being maintained in a good way. In order to do that, we're going to relax how much all of these nodes or all these machines have the data that they're looking at. They're not 100% consistent all the time, which allows us to, if we relax that, to actually get into other models, and we can build the database in another way. And that's actually something that works pretty well with a lot of the systems that we see out there, the applications that we're working with. Consistency, 100% consistency is not something most applications really need. And so that's an area where we're going to really relax. Another one is related to isolation. Another part of SQL really allowing for all these applications or all these different queries to not interact with each other and get in the way. And they do it in a very strict way. There are ways to achieve very similar goals without needing to be quite so rigid. And that allows for more concurrency, more concurrent users and queries going on at the system at the same time. Another thing that we see a lot is if we look at a database, a relational implementation, something maybe in Oracle that has a lot of stored procedures in it, you're basically asking the database to do a lot of your application logic in the database. And that can really put a big amount of pressure onto the system itself, when really we'd really kind of like to see that system major in just maintaining our data. So yes, there are some things that do make sense to maintain inside the database, but a lot of application logic was put into the database. And that meant that as more of that the database started doing more of that core work, meant that the DBAs who were responsible for administering the database really tried to keep very tight control over who had access, which actually made sort of this adversarial relationship grow up between the developers and the DBAs, which really was completely unwarranted and really not necessary. And so Cassandra sort of looked at that and said, let's take that part out as well. And then we're going to adjust. Now that we've done some of these relaxing and revisiting of how we want to approach things, that bleeds over then to how are we going to exploit the benefits that we've got. And this idea is not unique. We did the same thing when I was at my data warehousing company, where you would find the strengths of the system, and you would engineer your solution or your application to leverage the best parts, and as much as you could. And the same sort of thing here. And that'll come into the way in which we're going to choose how we model our data, how we put it into the system, how we query it, et cetera. It's also a little bit on how we're going to act and structure our application, not just the data itself, but how we interact with that data and where we do certain operations, et cetera. So a lot of times people will talk about, we're going to do this very differently. We got to get you to think entirely differently when talking about Cassandra versus a SQL database. And I think that that's not quite right. I think that it's not that you're actually doing different things. You're doing very similar things, but you're doing them and approaching them slightly differently. And so it's not a throw out everything you know, as much as let's talk about what Cassandra does exceptionally well and try to use that part of the system as much as we can. So that's kind of Cassandra's high-level approach. We dive in next level down into what does it actually look like. So Cassandra still has rows and tables. I refer to it as a partitioned table data model. So I mentioned before that it is going to take multiple machines or multiple nodes to do the management of the data. And that means that we're going to slice up this big table and put pieces of it on each of the machines. And the way we're going to do that is by partitioning it. And we can get into the details of that. I'm not going to get too deep on this talk. There's a lot of material that I'll point to at the end. But you can just think of it as we carve up this table and we spread it around to the different machines. Table still has columns and rows. I mentioned before, we like columns and schema, and that's sort of the approach here. Tables live inside something called a key space. So just to take a step back, some of the language here looks very similar to SQL, and some of it looks a little goofy. Key space is an example of one that looks goofy. In the origins for Cassandra, did not start with a table data model. It had a different space. We talked about column families and key spaces, and the language was a little different, and the schema was a little more flexible or really not as strict at all. And around 5 or 6 years ago, really, this new idea of the Cassandra query language and this tabular model came along. We changed a lot of the language, but we kept some of the old language. So here we have the word key space. Key space is a holdover from that former sort of model, but really it's just a database or a schema in the relational language. So I'm going to call out some of the language that looks a little different, really just to highlight that it's really just the language that's different and not so much the concept. This key space is a namespace. It allows for tables to be in it, so you could have the same table name in multiple key spaces. And actually within Cassandra, it's also where we'll control replication, how many copies are going where in the system. So that's just a little bit of a diversion, but we've got tables, we got rows and columns, and they live inside of a key space. The schema, like I mentioned, around 5 years ago, we really kind of solidified around this Cassandra query language and this tabular model. We like this. It's got, like I mentioned before, rows and columns are really, really natural. And by having a schema, we can ensure that as the data is being put in, that it's actually valid. So we're not accidentally putting a string into a floating point column. Each column represents a particular attribute of the data. It might be name, it could be height, what have you. And they have particular data types. In addition to the SQL data types, things like strings and integers, et cetera, there are some extra types that I think is not uncommon in a lot of newer databases where we have collections, lists and sets and maps, and then even the ability to define a user-defined type. And those are really, you can think of them as more like structures made up of other regular type things. So it might be an address has got a string for the street address and a string for the city, a string for the state, and maybe it's a number for the zip code or what have you. And then you can have that as a type. So we got columns and rows, the data being validated on the way in. And then rows are rows. There's not really much to be said about rows. So how do we interact with this? And this is, again, where I think we'll start to see that the CQL language, the Cassandra query language, really does look an awful lot like the relational's SQL. And that's for a reason. For people who are coming to Cassandra from elsewhere, there's no reason for you to go learn a whole new crazy language. It may as well sort of come and meet you where you're already familiar. I mentioned before, I came from a data warehousing company. It was a SQL data warehousing company, and so this was actually very, this resonated very well with me. I understood DDL, I understood DML, and then it became a matter of understanding what the extensions are that are unique to CQL versus sort of standard SQL. So we still create objects here with DDL. We can create key spaces. We can create tables within key spaces. You see on the right, we've got this stock symbol example, and we've got, regular columns. We got symbols and transaction times and prices and the side. And then this primary key directive, which tells us about uniqueness. And this says that if two records have the same values for their primary key, then it will be overwriting the existing data. So we don't do a check to make sure that it hasn't been in there before. There are ways to do that, but those are the rare cases. So this allows us to keep, for instance, the symbol, and there's one value for symbol and date pairs, and that's a handy piece to handle here. You have the flexibility to define that however you'd like to define that. When you do queries and you want to select data out or insert data in, it looks very much, again, like SQL. Here we see we're selecting a couple columns from the stock symbols or stock price table, and we're restricting by some of the primary key columns to be able to understand or get that fraction of the data. Very, very straightforward ideas. Similar to we've got this DDL for create, we've got DML, we've got insert, update, delete, and select. There's also the typical permissions granting and revoking and creating users, et cetera, all done in a very analogous way. So I've said a few times it's analogous, it's similar, but it is not entirely identical. And that's, again, going back to that premise of we want to take a look at some of the promises that relational made and relax some of those. We're also trying to major in very particular operations. Cassandra is designed for high concurrency, lots of queries coming in at the same time, low latency, so very short millisecond or even sometimes faster responses. It focuses a lot on being able to handle writes and at a very efficient way. It's one of the standout pieces. And so as a result of trying to sort of focus on these major pieces, there are parts of the SQL standard that are missing from Cassandra. An example is probably the big one is joins. And so similar to the data modeling, and we'll talk about this a bit in the next slides, but similar to some of the data modeling techniques, even in SQL, when we don't have a join or we try to avoid the joins, we model the data to handle that. And I'll talk about that on the next slide. But I do want to call out, it's similar to relational, but not identical. So it's not a surprise. So as a result of some of those differences and the way that we've kind of laid out some of the description of how this data should be modeled conceptually, how do we do it in practice on real problems? So the first thing I'm going to call out is we kind of approach things a little backwards. And a lot of times folks talk about this as a very different way of thinking. I got to be honest, it was a very natural way for me to adopt this sort of this methodology or approach that the Cassandra community really talks about. In the relational world, there's a very sort of canonical way of looking at data. There is data, it exists in the world. I will model that data in a very canonical way using some very standard approaches that are formalized. And we get things like third normal form, and we get these very sort of elaborate but tidy data models. And then we take a look at the questions and the queries that we're trying to do, and we look at the data as it's been modeled in the world, and we sort of map our queries to that data model. And so we sort of start with what's the data look like, how do we frame that in a formal way, and then let's apply our questions to it. When we look at this in the Cassandra and DataStax world, really flip that around. We have a concept of the type of data that's available to us. You know, maybe we know the columns that are available, the attributes that are in our data, but really we start with the application and the questions. What are we trying to do with this data? What do we need to be able to support for the business? Are we looking up, we need to be able to retrieve from our user or our list of users, we need to be able to retrieve them by email address. We might need to be able to retrieve them by when they were created so we can find out who's new. Maybe we want to go give them an offer. So understanding how we're going to access this data really comes up front. Once we know that, we can take a look at what form should we think about our data to support those queries efficiently. Again, riding the most, the best parts of Cassandra and avoiding some of the other parts. And then we take that conceptual model and we apply it to the data at hand and build the proper schema that supports it. So as much as that sounds very unique to Cassandra and DataStax, I'd argue that's actually a pretty common way to approach things also in the SQL world as well. It was a way that we did it a lot with data warehousing. In fact, I do see a lot of parallels between the way you model for data warehouses and the way you model for Cassandra, which is a little bit strange in that data warehousing is really about chugging through a lot of data and getting understanding of it, summarizing it and slicing and dicing, et cetera. Whereas Cassandra is really about a much more low latency, lookups and inserts. But they do share some really, one important common attribute, and that's denormalization. So in the data warehousing world, we denormalized so that we didn't have to do and spend a lot of time joining data together in order to analyze it. In Cassandra, we denormalize so that each question that you might have of the data is already essentially gathered together, and you just need to look it up by the business keys that you're going to use to access the data. So the goal is really to answer the query from a single table. And that may mean that we might need to store the data that we've got more than once. If I have a user table and I want to be able to look them up by email address, I might need to organize the data for that kind of query. I might need to also look them up by their last name or last name, first name. And to do that, I might need to have another copy of my user table organized in a way that supports that query efficiently. This idea of sort of copying the data or storing the data multiple times is not uncommon in I would say data management in general, but it's a really important tool we use in modeling data inside of Cassandra and DataStax. You can get kind of carried away though. If you have a lot of queries or a lot of questions that you want to ask of the data that are really different, you can end up going, geez, do I really have to store this data so many times? And the answer is not necessarily. First of all, sometimes you can get clever and reduce that number. But we also have some stuff in DataStax Enterprise, which takes Apache Cassandra and adds some additional capability that allow for these more flexible queries, and called DSE search. Not going to talk about that here, but since we're sort of coming close to that topic, I figured I'd just make a passing reference. And that allows for kind of covering a couple different query patterns in one sort of structure. And then this other thing, I'll mention it here. It sounds a little bit strange, but we'll come back to it in a few slides. Item potency. So that's a new word for me when I got to DataStax. I like funny words, and that's definitely one of them. But the idea here is that the data can be, you can make the same insert statement or save statement multiple times, and the state of the data stays the same. Okay, so that sounds a little weird. How would it be that if you saved the data more than once, the same thing more than once, that it would be a problem? I'll give an example. If what you're saving is an incrementing counter, and you want to say how much you should increment, if I say that twice, then I have incremented twice, and so my value goes up more times the more times I save it. And that's just an example. It could also be something like appending to the end of a list. If I do it again, then I've appended it a second time. We're going to want to design things so that when we write them in, it won't be a problem if we were to write exactly the same thing in again. And that's usually not a very hard data modeling concept to put into our data model, but it is something that really aids with how we're going to approach this in an operational setting. It means that if I'm unsure of something, I can always write it a second time and be safe, kind of take a belts and braces approach to this and not goof up my data. Now, if we look at, that's a little bit on how to approach the data modeling side. If we look at how to approach the application side and how do we build our application around this, another thing kind of jumps out. I touched on this before, that one of the challenges we see with SQL and relational databases is really not really SQL, but is the additional logic like PLSQL or something like that, a stored procedure language that is stored in the database, now requiring the database to do all this extra work. It also requires you to work with, if you're a developer, to work with the DBA to make changes. So management of that logic, that business logic that you've put into the database can be more difficult. That's more organizational, but I think we've seen enough times at organizations that this is the way things have happened to sort of call it out. In the NoSQL world, especially in the Cassandra space, we really talk about taking that logic and pulling it out of the database and putting it into the service layer. So I call it the service layer, not the application layer. I think of the application in this, at least in this picture, as sort of running on that laptop picture on the left, and then talking from that application to a service that will manage your data in the database for you. So we're talking about taking on the left a very simple service and a very complicated logic in the database, taking that logic and pulling it into the service and letting the database major in data management and letting the service coordinate how the data is being accessed and saved into the database. Note we're really not talking about adding more logic. We're really just talking about where that logic lives. Also, by moving it into the service, I don't need to work with the DBA to change how I'm working on my application, and that's attractive in terms of rolling out new features. It's one fewer component to coordinate in a potentially a big organization, and so that's pretty attractive. With this new approach, there's a couple of new data modeling patterns that we've seen that kind of come out, or application patterns that we see that are sort of been coupled with Cassandra quite a lot. The first one is microservices. The idea in microservices is you break up a big application into small pieces, and each piece kind of has the autonomy to decide how those should be best implemented, and then you have them interact with each other in a nice way. Typically, there's some kind of an orchestrator process service that that the applications communicate to, and that orchestrator is responsible for interacting with each of the different microservices underneath. It allows for some decoupling of things, which can be pretty handy. For instance, if all of a sudden the fidelity of your data jumped from, say, every minute resolution of your data to every second resolution of your data, you might need to scale out one or two parts of your system, but the other parts really are insulated from that. And so we can scale that independently and not disrupt all the rest of it and worry about a big rollout together as one big application. One of the common patterns that we see in microservices that's kind of handy is event sourcing. And event sourcing is, instead of making updates to a table by updating records themselves, we really just write it as a time series. We're going to add new events to the time series as we go. We're going to just basically give a log of what's been going on here. So you could think of it in sort of finance as thinking, instead of keeping a balance in your database, you would actually keep the transactions that have been put into the into that account in the database. On read, you can read it all out and summarize it. This allows you to actually do more than one thing with the data, which is kind of handy. And sometimes there's persisting of those summaries for really common access patterns that come into play as well. The other thing that we see, and I'll make a shout out again to DataStax Enterprise, is one way of looking at it, but there's also other technologies where you would match your Cassandra application with other technologies to solve other parts of the problem. So just to make sure that we're looking at the full set of tools that are available to us and deploying all of it to bring to bear on the problems. Okay, so I had mentioned that I was going to do a little bit on Cassandra, and so here's a very, very high level view. This is my caveat up front that if you are interested in what you see, reach on out to us, take a look at some of the resources I'll mention at the end for a lot more detail that gets into the nuts and bolts. But there are a couple pieces for this conversation today that are worth having a quick conversation about. One of the core pieces or core design decisions of Apache Cassandra is really that there is no special node. All the nodes in the system are identical. It allows for some simplicity of deployment, but it really hammers on two important characteristics: availability and scalability. Because each node is identical, we really are able to leverage and realize this sort of high availability and realize the scaling out in a linear fashion that brings to bear. So with respect to availability, no single point of failure. So no node is actually any special here. Other systems sometimes have a head node or a master node, and then the others are followers. I mentioned before that the data is replicated, so there's multiple copies of the data in the system. There isn't a special leader for each of the replicas. They're all equivalent. And that means that we don't really need to worry if a node goes down. So in this example, we've got this node, this black one that is down, but the same data is in these two other locations, and so we can retrieve it from there. So as the data is being replicated around, we can tolerate a node being down because that piece of information is available. Similarly, on the client side, we can kind of connect on in to any node into the cluster to discover the whole cluster. All right, and so the client here has connected into that top node. Once it's connected, it knows the whole cluster, and if that one node goes down, the client will just seamlessly use the rest of the nodes. All nodes in the system will manage data and queries. So I don't need to query a particular node to get to a particular piece of information. I can actually ask anybody. And if I ask anybody and that person owns the data, they'll be happy to give it back to me. If they don't own the data, they will take it as their responsibility to go find that information out for you. So it's sort of, they become your maitre d', and they go and grab the data as needed. So we don't have this, we don't need to depend on any particular node to manage the data. We don't need to depend on any particular node to query the data. We can ask anybody any question. And so we really realize this sort of best-in-class fault tolerance. On the scalability side, because all nodes manage data and respond to queries, if we need to manage more data, let's say that we are now getting, we decide to retain the data longer. We were doing 30 days and now we want to do 120 days. We can just scale the system to manage more data linearly as we go. Similarly, if we decide that we need to manage more transactions, maybe the fidelity of the data is coming in has gone, like I said before, from minutes to seconds. I now have a lot more data coming in. I can scale the system to handle that many more writes per second as well. So it's a very simple, card to play, and it covers these two main value propositions of Cassandra. The other one that we haven't really talked much about here, but does come up an awful lot in conversations with customers, is really around supporting multiple data centers. Typically, that's to support data in multiple locations, though there are other use cases. But you can think about it as having like an East Coast data center and a West Coast data center. We want to replicate the data across between them so that we have the same data available in both places. Most of the technologies, the legacy technologies, really do that as kind of an afterthought. So we look at something like Oracle and Golden Gate, where it was thought of as a single data center, and then we now try to bolt on this after the fact idea. It was a core tenet of Cassandra from the start to be able to handle this. And so we do allow for this sort of multiple data centers, and we have strong semantics around who's getting the data when and how. We can configure which data goes where. It's not just a straight copy everywhere. And that's handy for things like localization. If I'm on the West Coast and I've got a customer coming from New York, I'd like to have the East Coast data available for them, and so it's more tailored to their experience. It could also be for more legal reasons, something like GDPR, where we don't want to have this data copied outside of the Europe and keep it there. So we can configure what happens where. Similarly, or in addition to that, rather, we can also have multiple data centers for disaster recovery or disaster avoidance, really, scenarios. In those cases, what happens if my East Coast data center just goes down, there's a power outage or something? Well, the application continues to run on the West Coast and it's fine, and vice versa. Similarly, we could just have a network problem where the two can't talk to each other, and the applications on the East and the applications on the West each are fine talking to their local data center. And that's a really strong value prop that we see. If we extend that a little bit, not just the multi-data center, we start looking at how we can play that card in sort of this new world. This is how DataStax and Cassandra really approach multi-cloud, hybrid on-prem and in the cloud, because we really just look at those cloud providers as infrastructure. So we can actually put ourselves into a situation of being across multiple cloud providers or multiple data centers is really the same thing. And this allows to leverage interesting things from each of the cloud providers. For instance, we may be including some third-party data, and that may be available from AWS. And so we want to put that into our AWS data center so that we have access to it easily and cheaply there. We might want to leverage some machine learning capabilities of Google, because they've got some great stuff that we want to leverage over there. So we have a copy of our data in the Google Cloud as well. And so we have this flexible deployment that allows us to really exploit the features of on-prem and in the cloud and the various cloud providers specifically. So talked about a little bit around the different, we've got this multi-node masterless architecture. That's a little different than the kind of typical relational databases you interact with. We've got this multi-data center situation. We want to exploit that. And that really kind of surfaces up into the driver, into the application. So the application's now interacting with the database in a slightly different way. And as a result of that, we're not really going to go through ODBC and JDBC to interact with Cassandra. Now, I will say that DataStax has partnered with some of the big driver providers out there, and we have a ODBC and a JDBC driver available that goes either against Cassandra or some of the other technologies as part of DataStax Enterprise. So they are available out there. I would say that they're more the exception than the rule, and many of our applications are going directly against one of our custom drivers. So we have a driver in many different languages. They all have essentially the same design or conceptual design. They've been implemented in a language-specific way. So in Java, it's got classes and methods, and it looks very natural to a Java developer, whereas in something like C is functions and structures, and that's very natural to a C developer, and same with Python and Node.js and Ruby, et cetera. The idea is that these are now able to connect to the whole cluster. They're able to balance the load and spread the load around that cluster so they don't overload anybody with asking all the questions to one node. They can be very smart. They can handle high concurrency and very low latency. They can handle asynchronous operations, which JDBC and ODBC kind of struggle with a bit. So this new flavor of driver really unlocks the power of this platform in a slightly different way. I'll say that, yes, there is a learning curve, but it's pretty straightforward. Like I said, the drivers are really designed to make this feel like it was designed for the Java developer, and the Python driver for the Python developer, et cetera. There's been a lot of work done to validate that experience. Because Cassandra is a distributed data source and it has multiple replicas, we can really talk about this consistency topic again. I mentioned it at the top. How many of those replicas for a piece of information need to respond in order for you to get acknowledgement in the write and the read? By knowing how many replicas have responded to a read or a write, we can actually tune how consistent this my application is, how its view of the data, and I can achieve immediate consistency. And by that I mean, if I wrote it into the database, I can guarantee that I'll read the most recent version coming back out. That's a knob we can turn. Not all applications need that level of consistency. For example, if we think about some of the IoT use cases, things like thermostats in a room, it might not be necessary to have the data be 100% consistent all the time because the temperature is not changing a lot. So it's a pretty slow-moving data set, but we still need it for our dashboarding and our application. But we might be able to lower the consistency to get some more performance. And we can tune that ourselves from the application. That's something you can decide in the app that you don't need to do in the database or in DDL or with the DBAs. One thing that we do with the DBAs is decide how the data is laid out. How many copies of the data are going to be in each data center, which data centers are going to get the copies, and we can organize that and explicitly direct the data through the system. That's another powerful one I mentioned before, sort of needing to direct the data to the right places. Might be for performance or cost savings, but it could also be for security considerations. And then lastly, we talk about transactions. Oftentimes with relational, we kind of come on in with the idea of I'm going to try to do this set of operations, and if it fails, I want to roll back the whole application transaction and pretend I was never here, right? So if something fails along the way, just forget all the things I just said to you, put it back the way it was, and pretend I was never here. That's an approach. It's a fine approach. I think the challenges there are that that's a pretty big a promise that you would be able to roll things back. It can be a little costly to undo an operation once it's been started. And that's the sort of area where we talk about, well, let's relax this. Do we need that? In Cassandra, we can take a slightly different approach because we're so available, and there is always going to be another node available to take this query from the application. If the query fails, we can try it again, and we can just say, all right, well, the node that I was talking to fell apart, and maybe it had a power outage, or it was taken down for scheduled maintenance, or what have you. I'll just ask another node. Since I can ask any node any question, I should be able to just do that. And this is where that idea of idempotency comes back. If I did a write and it gets a failure in some way, I can say, all right, well, I'll just write it again. And if for some reason there was an artifact of this sticking around in the system, well, there's no harm in me writing it a second time, right? And that's sort of this idea. So instead of rollback, we do retry. And I think of this as an important piece because if you needed to write the data into the database, like if you had something to say, then we should try to save it. I've always been a little worried about if you rolled back, then what? What happens to this piece of information you wanted to do? Do you have to go back to the application and say, sorry, user, we can't do that for you? Or do you really want to say, give me a second, I'll try it again, and I'll be able to give you what you're looking for? And I think that latter idea really resonates with me. So that's kind of a very high level piece. See, you weren't in trouble. There's a lot of ways in which Cassandra is similar to SQL, and that's the part that I tend to like to focus on. I think that the they-sayers out there can probably be ignored at this point. Some of the differences that come up are actually pretty nifty, right? The availability and the being able to place the data in particular places, being able to be flexible with consistency is a really valuable and powerful tool. And then, of course, don't forget about DataStax. We're here to help, right? Big contributors and players in the Apache Cassandra community. We've got additional sets of tools and capabilities that go beyond Cassandra in DataStax Enterprise. But we're the experts with Cassandra, and we're here to kind of shepherd you through the transformation. I'll put up just a couple of resources. I mentioned DataStax Enterprise. That's kind of our flagship product, and you can read about it on datastax.com. A whole set of documentation, both on the open source and CQL, which is common across, as well as DSE specific pieces. Academy is a huge resource. A lot of self-paced tutorials, classes that are actually very involved. Also short nuggets, blogs and webinars as well. And then of course, we're on Twitter, we got a community page. And so we're all over the place on the web. If you got questions or just hungry for more, lots of places to go for that. So with that, and open it up, I guess, for any questions that might have come through.
Yep, it looks like we had a couple of questions come in already. So the first one is, why do some people refer to Cassandra as a wide column store database?
Yeah, it's good. It's a good question. It's not my favorite way that the world calls it. It's a kind of a relic of the way that Cassandra started. So if you go onto something like DB Engines and you look at Cassandra, it's listed as a wide column store. That goes back to the days before CQL and before tables, and goes back to this column family. That world was pretty painful. There wasn't a query language like Cassandra query language. There was really byte buffers, and you had to do a lot of very low-level programming to get there. And what really happened was this observation that very similar patterns were happening with the data management and data access that allowed for us to sort of create the Cassandra query language. So yeah, technically under NoSQL, people will call it a wide column store. I think that the partitioned table store is now more appropriate, but that's been the way it was from the beginning, and so that name kind of sticks with us even till today.
And another question is, how is denormalization different in Cassandra than SQL data warehouses?
That's another good question. I mentioned that a little bit before. I mean, I think that they're very similar. When I was in this data warehousing company, it was a distributed data warehouse, and we had to think about sort of how data got laid out and the partition keys, or how we split the data, knowing how we were going to query it. So if we were going to do joins, it would be good to distribute on the join key. Or if we were going to do group bys, we would want to distribute on the keys that we were going to use for that, and it would minimize the amount of data we had to move around. So this idea of understanding how we want to lay the data out is similar. But in terms of denormalization, again, it comes back to wanting to have the data ready to be used without having to collect it from various places. So that denormalization, a lot of times you would take dimension columns and denormalize them into the fact table. You could think of in Cassandra, it's just a fact table, and we don't join, we put those other pieces along with that fact table. It allows for lookups to have all the data that's necessary. Now, there are times where you would need to actually combine information, and for the cases there, we have approaches that really kind of deal with that at the application level and some other higher level tools. But the denormalization is really around trying to have all the pieces already co-located, when we go to read them.
And next question is, if you do need to combine information from two tables, what is the best approach in Cassandra?
All right, I just started talking about that, but yeah, so the idea there are a couple of options, right? So the first piece is, we tend to see a lot of folks, I mentioned before in the microservices approach, that there's this orchestrator who orchestrates among multiple microservices. And so that would be one way to handle this, if you think about each microservice being a table, where in our application or in our service, we would actually be doing some retrieval of data from one table and using that to determine what we're going to retrieve from another. And so we can do that in the application itself. There are some other tools and techniques that DataStax Enterprise puts into place that help surround this. And one of those is DSC Analytics. Now, there is an open source analog, I'll say, to that, which is to marry Apache Cassandra with Apache Spark. And that's Spark is a processing engine, a distributed processing engine that can do all sorts of things. But one of the things it can do is read from data sources, multiple data sources, let's say, combine the information and do stuff with it. So we have also seen Apache Spark as a way to do some of that combination of data. And then we package that in DataStax Enterprise that delivers both Cassandra and Spark together. So you can combine that in the application itself. There are some other pieces that get into sort of graph data models and other things that bring other tools into play, that are sort of other things that are out there. But I think if we focus on Cassandra today, doing it in the service or in the application layer, or leveraging a framework like Spark is probably the two big ones that I've seen as how people approach that.
Does Cassandra allow for batch write operations and or have a stored procedure language?
Good question. So batch operations, really important for loading data in bulk. I've seen a number of cases where customers have kind of delivery comes to headquarters as big files, and they need to load that into Cassandra. So there is batching. There are batch ways to do things in Cassandra where we're going to load a bunch of records at once. We don't tend to do very large batches. We keep them in bite-sized pieces. That keeps things moving very nicely. And there's some tools that are out there that really help approach that, how to load data in bulk. And we also see that as something that I mentioned the Spark connector leverages some of these bulk techniques as well. In terms of a stored procedure language, that is not part of Cassandra. That was something that we wanted to pull out of the database and let the database, again, major on data management and let the let the applications handle the logic. So we tend to see that application logic kind of like the picture I was showing, where we pull the PL/SQL out and we put it into JavaScript or Java that's running inside of the service layer. And so there is not a stored procedure language, but most people are actually kind of happy with having the data that logic outside of the database.
All right, so we do have time for one more question, and that is, do you have recommendations for how to get started? What learning resources or tools do you recommend?
Yeah, absolutely. So a couple different of things to call out here. It's a good question and probably a good one to end on. So I mentioned here's a couple of resources here. The downloads page from DataStax, you can download the product yourself and install it if you've got a spare machine, and there's tools there as well. There are some other quick start pieces. We have a product that's in beta right now of a cloud offering called Apollo that you can also find, and that's sort of it's in beta form, but you kind of do some clicking and then a cluster will be provisioned in the cloud. So that's kind of an easy way to get right to the, I want to play around with SQL and I don't want to have to stand up the database. There are a couple other tools in that same sort of area. DataStax Desktop tries to do something in the sort of desktop version of that. And then I'd have folks also check out Studio, which is a development environment that you can also get from the downloads page. That is a nice, simple notebook way of interacting with it. There's a whole host of content available on Academy. So that's classes if you'd like to go through it linearly. There's blogs and sort of articles around various pieces to really get an understanding of what's going on there. There's a great distributed data show that we've got that sort of discusses various topics around, so it's kind of a podcast. That used to be a video, I think it's now audio only, but it's sort of a podcast that lets you talk about a lot of stuff. So there's a lot of content. I'd probably start with Academy and with the download page and Apollo to kind of get going.
Okay, great. I believe that is all the time we have for today. Thank you, Brian, for a great
Thanks.
presentation. Again, that was Brian Hess, the Strategic Solution Engineer at DataStax. I would also like to thank DataStax for sponsoring today's webinar, as well as the attendees for joining today. Until next time, I'm Jacob Lukowitz.